Let's try again. So we're here to present a new selection technique for mid-air gestures. So normally when you use pointing in mid-air gestures, you need some mapping between the system's coordinates and the user's coordinates, and a cursor on the screen to indicate where you're pointing. So if I'm pointing there, it is really difficult for you to figure out which one I'm trying to select. But if these targets are moving, and I move my hand in sync, the system can actually use the correlation between the movement of your hand and of the target to figure out which one you're actually trying to select. We call this technique PathSync, and this is work that we did at the Microsoft Research Center for Social Natural User Interfaces at the University of Melbourne in collaboration with Microsoft Research Cambridge. So, we're not the first to propose this principle. So, John Williamson has done a lot of work on this with Brownian motion and changing orientations. Melody Vidal did this with gaze for selection in public displays. And my own work has explored gaze selection through movement correlation on smartwatches. So, these works show that these techniques work for gaze, it worked for the mouse, but we weren't really sure whether this would actually work for mid-air gestures. So we ran a data recording session to identify the parameters that would fine-tune the algorithm for this context. So our study set out to answer 3 questions. First, can users actually do this? Can they actually accurately match the movement on the screen? Second, what are the effects of the movement, or the movement properties on users' abilities to match this movement? For example, the shape and the speed of the target. Finally, how many targets can we actually put on the screen and robustly distinguish? So we conducted a data recording session with 20 participants, 18 of which had little to no experience with Kinect-based interfaces. So this is what we presented to our participants. So we showed a moving target randomly placed on the screen, and we just recorded users' hand movements while they tried to match the movement. So we used these 5 shapes: a circle, a square, a diamond, a rounded square, and an irregular squiggle to really push the difficulty there. So in total, we had 5 shapes. We also tried 3 sizes of the shapes and 3 speeds for a total of 45 trials per participant. So let's see how we actually calculate this correlation. Let's say a user followed a target for a certain amount of time, right? So for each window, we compute the correlation of the coordinate of the user's hands with the coordinate of the target on the screen in both axes. But the problem is that Pearson's correlation requires some variance in the data to actually be able to compute the coefficient. So in this case, for example, there's a lot of variation on the x-axis, but not much variation on the y. So we use the eigenvectors of the shape to actually rotate before calculating this correlation. So you see that the variance is distributed equally across both axes. So we also use a double threshold to actually indicate a selection. So when the correlation crosses the upper threshold, we highlight the target, similar to a hover state in a pointing-based metaphor. And after a certain amount of time with the target highlighted, we actually trigger an activation and only deactivate when it crosses the lower threshold. So we for each trial we computed whether a selection would happen, and we found that all of these there were no statistical significance in the difference between the accuracy of these shapes, but the squiggle was just rubbish, so we just discarded it from our further analysis. So to answer the question, can users do it? Yes, they can. So we also tested the effects of the shape and the perimeter of the shape and the speed on the minimum offset that you need between 2 subsequent targets moving along the same path to be able to robustly distinguish them. So we found that for the circle and the rounded square, we needed a minimum of 37 degrees, and for the square and the diamond, we needed 28, which means that you can put up to 12 targets on these shapes and 9 on those, and you can double that if you consider different directions. So this means that you can actually have an interface with up to 24 buttons and have a target moving around each button, you can still robustly detect which one the user is trying to select. And so we were intrigued, like, why was it that the square and the diamond actually worked better? Because we thought that, it's quite easy to do a circle, but it was actually because they give a point for the user to sync up, which is explained if you look at how jugglers think about this. So novice jugglers are instructed to look at the top of the movement to actually sync up and time their throws. So another interesting analysis that we did was we wanted to see whether the position where we were displaying the movement would affect how people actually did the gesture. And we found a moderate correlation there between where we placed and where the user would do, where we placed the shape and where the user would do the gesture. So if we placed the shape on the right of the screen, people would do the gesture here, and if we placed on the left, they would do the gesture there. So there is even though you could, in theory, do the gesture from anywhere. But okay, so in this study, we only did this analysis offline. So there was no feedback to the user. There was he didn't know that it was actually triggering anything. So does it actually work in an actual selection task? So to answer this question, I welcome to the stage Dr. Marcus Carter.
Thank you. So in order to do that, we ran a comparison study between PathSync and Press to Select. Press to Select is the gesture interaction technique that was previously on the Xbox One, and we considered it the commercial baseline. In this study, we really wanted to also, as well as seeing could people use this as an actual type of interaction, is can people learn how to use it? This is a really different way of interacting with touchless gestures. So we ran a study with 40 participants. 37 of those had little to no experience with the Kinect before, and we were careful not to identify to those who'd never used the Kinect which of the techniques was ours and which was the one that previously existed. So in the study, we had 8 blocks, 3 trials each, alternating between the 2 techniques. This was the tutorial that we developed for PathSync based on, it's just a horrific plagiarization of the tutorial for Press to Select from the Xbox One. So the users first get feedback with a lower threshold to interact with the square, and then we raise the threshold with an increased activation time for the initial feedback, and then we ask them to select between 4 different shapes. And I'll just play now a clip from the trials, just to give you a sense of how it works. So each of the categories was a different type of category, like pick the animal, pick the public transport with a symbolic symbol. And this is based on the Metro UI, which has Press to Select has been optimized for. So we wanted to find a context where we could really compare this technique to Press to Select on its home ground in a way. So 39 out of the 40 participants were confident that they understood PathSync after completing the tutorial, while 21 were unsure about Press to Select at the beginning. We don't really have an explanation for this significant difference. It wasn't clear in the interviews why this was, but we were really stoked with that. There was no statistical significant difference between the error rates with the 2 techniques or the completion time for the 2 techniques. So quantitatively, we found the 2 techniques are comparable. But what about qualitatively? So we asked each participant at the end of the trial which of the techniques they felt were faster, easier, and less frustrating. 22 of the participants felt in all categories PathSync was better, while only 6 were sure about Press to Select. The remaining 12 were unsure, considering one better for some factor, the other better for another. We obviously go into a lot of detail in the participant responses to the technique in the paper, but I think it's best exemplified by this quote. It's different, it's weird, but once you get used to it, you know it's what you want. We were also curious in the design whether participants would find the movement on the screen from all the targets distracting. 4 of the participants did mention that they felt that they were distracting, while the same number felt that they needed to be more obvious in order to draw your attention to the movement and more easily see them from standing 2 to 3 meters away from the large television. These are some of the other comments that we got about PathSync, that it was responsive, less sensitive, less tiring than press to select, and that it required less concentration. So this was great. We were really stoked with the results of this, that we were able to show that the technique was comparable to press to select. But this is in a lab setting. This is a very strange interaction technique. It's not using a metaphor that users are familiar with. So we wanted to go out into the wild and test it out on public screens in 2 locations. The first of these is in a hallway. This is where there is an extremely low threshold for interaction, and several thousand people pass through this, and it's on our university campus. The other is in the corner of a shared study space outside of a library. So these two, this also gave us an opportunity to look at the social contexts of the use. So we developed a game called Social Nuiz. And with this, we wanted to look at the discoverability of this interface. With no researchers present out of the lab study, would people be willing to learn this new interface and successfully use it? We wanted to examine the social affordances of the gestural interaction technique. Cursors can sometimes be quite annoying for multiple users. To distinguish between our cursors, and also they reveal your interactions. In a quiz game, this is obviously problematic. You don't want to give away what your answer is, so a cursor isn't appropriate. And it's actually really difficult to match up someone's movement and to the particular target that they're showing on the screen. So I'll now play a video of the game. So while there were no users present, we displayed "Come Closer" on the right-hand side of the screen. And the only instructions they got was this little image on the right-hand side, and the instructions: select your answer by matching the dot with your hand. The silhouettes were extremely successful in attracting people's interest, and this is seen in prior work. But we also found that they gave away what people's intention was, because you could match the silhouette up with the target on the screen. So when, after the first round, we turned people into these disembodied bars. Another useful aspect about this interaction technique is that we're able to attribute an interaction to a Connect body ID, allowing us to track an individual user's score as they continue to play the game. So we ran this application for 28 days. We had 851 single users, 176 pairs, and 38 groups of 3 or more, giving us 1,065 during this period. We conducted 26 observations, which took 6 hours. During this, there were 5 people who observed the screen, but we observed no discernible attempt to interact. There were 8 failures. 4 of those thought it was a touchscreen. The other 4 were correctly understanding that there was movement needed in order to interact, but they weren't standing in the correct place for the Connect couldn't detect their movements. The remaining 13 had successes, where we saw a lot of really interesting social affordances of the application, and that it was able to, and that once one user was using it, that kind of drew more people in, which has been also seen in previous studies of public displays. So to conclude, PathSync is a new mid-air gesture technique that works through movement correlation. It's cursorless, which has social affordances, and it also allows for discrete interactions. It's discoverable, as evidenced by the public display study, and it's comparable to the commercial baseline technique, press to select. I think that's it. Thank you very much.
Hi, Anna Veit, Aalto University. Did you make any observations on ergonomics and performance of these gestures? How far could you push it, for example? How quick could users perform those gestures? So could you do more faster tasks than just single selections that require speed, for example? Or do you have to do it like that, or could you also do it like this?
Yes, thank you. That's a terrific, really good question. So in our study, we were using a 1-second threshold. So that was not... We haven't really explored the opportunity for both kind of how fast can we push that with as users increase their expertise, and also more complex transactions. So can people do a series of interactions using that technique? And I think that's really exciting for future work. But on the ergonomics, some of the users in the comparison study considered that PathSync was less fatiguing, and that was we believe that that's kind of for two reasons. Firstly, in order to interact with objects in the kind of upper right and upper left hand corner of the screen with a cursor, you have to fully extend and then extend more, which is kind of where a lot of the failures were happening. But also that's kind of a very fatiguing gesture, whereas in all cases, while we saw that people were moving their hand around to match with where the targets were on the screen, those users were generally quite constrained to this lower level. We've also explored really cutting that activation window down, and we found that we've been able to do it quite quick, but also that you're able to do it rested. And that has been proposed in prior work as a solution to the gorilla arm problem. We're excited about maybe extending this and exploring this further in finger gestures as well, which would, using the same underlying principle of matching movement, could further reduce concerns with fatigue.
And also, you can make the detection a bit speedier. So you just reduce the window size or reduce the threshold. So you can kind of tweak the technique depending on the setting. So for example, maybe in a public setting, you can be a bit more forgiving, and for kind of tougher, like more kind of sensitive situations, you might increase these thresholds.
Following up on both of those things, one thing you might want to look at is bits per second. It's used in the locked-in community to say how fast can we do these interfaces, and it's perfect for what you're trying to prove here, and you can optimize that parameter. Second thing is I'd encourage you to look at the signing box. So we have an existence proof of people who use sign language all the time, and they generally are doing this, and that's comfortable. You can sign like that for hours, right? And if you constrain your movements to that, or encourage people, if they made through avatars, you might reduce some more of the gorilla arm problem.
Those are really interesting. That's really helpful. Thank you.
Great suggestion.
Thank you very much. Are you planning to tap into people's rhythmic abilities to even go to sub-menu selections, because they can non-synchronize, slow down to the half tempo and select one part of this? Is that a good direction?
Yeah, we think that one of the advantages of press to select is that it allows for kind of complex transactions, particularly where you've grabbed something and then you can, or cursor-based techniques, I should say, allow you to grab and then do things with that once you've grabbed it. So I think that in order for this to not necessarily replace, but as we've shown that there are contexts where this works where other techniques might not, that I think it's necessary to add in kind of complex transactions to be able to do it.
And something that we've been thinking about is really about, because interfaces are designed to be stationary most of the time. So when you're using a movement paradigm for selection, you need to really rethink how you actually design these things. So one of the things that we observed in the public deployment is that people would actually try to, because the shapes looked like buttons, people would try to touch those buttons. So we really need to rethink how you actually the graphic design of the interface really. So for menus and more complex transactions, you really have to work with different metaphors.
Sorry, can you go back in your slides to where you're doing the amount of path around that you need to do to trigger the which selection it was? Because I really didn't understand
the correlation.
Yeah, how long you did it as number of degrees. 30,
oh yeah. So we were simulating targets moving around the same shape in one degree increment. So, for example, how well would it detect if the target was offset 5 degrees behind, for example? Because so the targets would be moving,
Oh, okay. And so
very closely. So we're trying to see what is the minimum offset that you need to actually distinguish them.
But doesn't that really depend on how fast the things are going as well? Yeah. Sorry.
Yeah, it's all right. Yeah. Thank you.